This is the beginning of Lesson 5, which is entitled Coordinate Moves. And this file is linked in the text below this video. And what I'm trying to get at here is a couple things. One is I tend to get distracted and my mind wanders and I start thinking about different ways to look at this math. And I try to look at it as an 8th grader. And so that's the reason for the counting strategy that I described below here and I've used in the past. And up here it talks about finding the center of rotation. 8th graders can do these things. They can find the center of rotation given some practice. They can use this counting strategy to check those rotations. And eventually they can use the coordinate grid to identify reflections and rotations. And so on the next page of this, I'm trying to get at that point that if you take an ordered pair, in this example I'm going to take point 8,3 and I'm going to label that point A. You can list 7 other related points to point 8,3, basically 7 other combinations of 8 and 3 using positive and negative values. And you can list them around the coordinate plane and you come up with those 8 points. Now 6 of those are reflections of 8,3 or rotations of 8,3. 2 of them actually are not. 3,8 is not a reflection over an axis or a rotation around a center point using the origin 0, 0. And neither is point -3, -8. Although 3,8 does show up as we go through this. And so the following tables, first of all, here's a summary of all of those moves basically in a coordinate grid. Kind of hard to look at all together, but again here are the 8 points and there's a little bit of color coordination there. So now if you look at each of them separately or individually, I separated those out into tables below. I'm not going to go through these in great detail, but what happens is you have to look at the order of the coordinates. And so I listed point A above for each one of these. So for example, this reflection, the order stays the same. It's still 8,3, it's 8,3, but one of the coordinates changes signs. And so what happens basically is this is reflected over the x-axis. It's as if you're traveling down the x-axis in both cases, and instead of taking a left turn or going up in the positive direction to A, you take a right turn and go in the negative direction to its corresponding point down here, its reflected point down here. So if you want to reflect point A to the 4th quadrant, so this is the 4th quadrant, this is the 1st quadrant, the 2nd quadrant's over here, 3rd quadrant. So you count actually in counterclockwise directions. This is 1, 2, 3, 4. So if you want to reflect the 4th quadrant over the x-axis, the x value remains the same. The y value switches signs. So you're just taking a turn in the opposite direction. Same with reflecting over the y-axis. The y value remains the same. So notice that's 3 in both cases, but it's the x value that takes a different sign. So so you're traveling up the y-axis, instead of turning right to go to point A into the coordinate 1st quadrant, you're turning left into the 2nd quadrant. So this is reflected, and it's the same value, just the opposite sign, because it's the same distance from the y-axis. Rotation, the coordinates switch order. So if you start with this point 8,3, point A, 8,3, switch the order, so it becomes 3,8. And actually, if you didn't change any signs, you'd end up here. And then the rotation to end up in the 4th quadrant down here is really a reflection of this point. So now you change signs. Instead of going 8 units up in this direction, you're going to go 8 units down in this direction. So the changing the sign moves this point to the 4th quadrant. And likewise, if you change the sign, so you change the order to rotate to the 2nd quadrant, change the order. So it's 3, 8, and you change the sign of the x value and that moves this point to the second quadrant before we move this point to the fourth quadrant by changing the sign of the y value. Yeah, a lot of words. It just takes time to look at it, think about what's going on, read through this text, and practice with your own points. Now there are a couple of special cases. This is a reflection over a line that's perpendicular to point A. So this is line segment OA, and if you go in the opposite direction, that's a reflection over a line that's perpendicular to this line segment OA. So you end up down here. Now notice, this is really two reflections. You reflect A to this point over here, and this is negative 8, 3, and then negative 8, 3 goes to negative 8, negative 3 as it reflects over the x-axis. So remember, it's like turning. Instead of turning north and going up, you turn south and go down to negative 3. So that's why the y value changes signs. And it all begins to make sense with some practice. Rotation, it's like two 90-degree rotations to get to this same point. So this is a 90-degree rotation. This is another 90-degree rotation. So it's a total of a 180 degrees rotation. So notice that two reflections, so reflect here and reflect here, gets you to the same place as two 90-degree rotations. Rotate here and then rotate again here. You end up at the same point, two 90-degree rotations. And here's the summary at the end. And so it just takes looking at what's going on with the coordinates in each case. So if I go back up to here, look at what's going on with these coordinates, what's changing order, what's changing signs, and depending on the order and this change in signs, you either get a rotation or a reflection. But think about why that's happening. We're going to use this information as we go through lesson 5, which again is called coordinate moves. It's just learning how to move within this coordinate plane. And actually, here's the numbering of the quadrants. So this is the first quadrant, positive, positive. Second quadrant is a negative x value, positive y value. Third quadrant, negative x value, negative y value. And fourth quadrant, positive x value, negative y value.